Hi, Kevin. How's it going?
Hello. Is it? It's normally at 7:30. I thought it was 7:15.
Uh, I've had to push it off because even right now, it's not my class from the lecture isn't loading up in time. So it's 7:30. I hate to do that, but I'm sorry I have to. I got to get that loaded before I can start doing this one. So I'm sorry about that, Kevin.
Okay.
Sorry. How are things going for you? Kevin, look at the, I believe you're having a problem with sig figs. Okay.
I'm the sig fig guy.
I
Dang it.
think look at the comments I made. Okay.
Okay.
If you're having trouble with sig figs, let me know because we need to go over that because some of you are having problems. Blake, are you there? Here yet, Blake?
Yeah, I'm here.
You're having a real problem with sig figs.
Okay.
I think, if I'm not mistaken, I could be wrong, but one of you two had you had a fantastic lab going, but you kept on screwing up on the sig figs. So I need to have you do that. I need to have you get those sig figs corrected, okay?
Copy that.
So if necessary, if you're having trouble with it, we'll have a Zoom meeting together or something. We need to get that down, okay?
I don't see
Yeah.
any
I'm sorry.
feedback.
I'm sorry, Blake. I'm sorry, Kevin.
Go ahead, Blake.
Oh no, you're good.
Okay, I'm just trying to get you upright with this, okay?
Yeah, I don't see any feedback in mine. My last two
Okay.
are like 80s.
No. Are you going to? Okay. All right. Do you see the screen? Kevin, do you see the screen? Do you see the screen now?
It says, yeah, I see it.
Okay. You go to quizzes.
Okay.
Okay. Once you get into quizzes, you go and find the one you need. Okay.
Okay. And it'll be
Once
under
you-
results.
It would be under results. We're going to go down here to results for standardization of sodium hydroxide. Go to results. Then, I'm sorry, excuse me. Then what you're doing is you click on the actual thing. Mine's not going to do it because I have different parameters than you. Crap. Let me do this another way, okay? View as a student, that would be better. View as a student would be better, okay? Submissions, quizzes. Then okay, there it is. Okay, so what you're gonna do, Blake, I don't know if you've ever done this before, if anybody's ever taught you this, but oh, okay. What you do is you go and find the one that you need. In this case, it's going to be results from standardization of sodium hydroxide. You click on the arrow. Then you go to submissions. And a box should pop up. Okay, it's saying I haven't attempted this quiz. But if you have attempted it, a box will say attempt 1. Click on that and you should get your feedback. Go ahead and try that. Okay, Kevin? Kevin, you here?
Yeah, I'm trying it now.
See if that works for you, okay? Okay, guys. I didn't mean to sign out. All right. The trouble is, you aren't the ones I need to speak with. The ones I need to speak.
Yeah.
You got it, Kevin?
I'm the sig fig guy.
Okay.
I'm not sure what I'm doing wrong, but I'm doing.
Okay, we'll talk later. Kevin, we'll talk later, okay?
Okay.
All right. Does everybody in here right now realize that when you are talking about a titration with a burette, the purpose of the burette is to You observe what the initial volume is. You let it go down to titration, then you stop it. Then you note what the final volume is. The amount that you actually delivered into your flask, the amount you delivered in there is equal to the final volume minus the initial volume. I had a lot of people that were just giving me either the final volume or the initial volume as the volume delivered, and that's not how it works. Are we all aware of that at this point, guys?
Yeah, I'm aware of that now.
Okay, are we good with that? We understand that concept. In order to tell how much a burette delivers, before you start the titration, you note the original volume or the initial volume. You go do your titration, it's going to go down. You note your final volume. The volume that's delivered is initial volume, final volume minus initial volume. That will give you the amount that is delivered. Does anybody not understand that right now? Okay, that, sig figs, and there's another thing. And again, guys, nobody that's in here do I need to talk to, because you all have been submitting your reports. There are several individuals that haven't. So I sent an email out in that regard. If you see it, don't worry about it. You guys are pretty much on the ball.
I have a question.
Yep.
At the end, when we do the results, there's always that one
Don't worry
that
about
says
it.
your instructor. Okay, because it just shows up as 0 for 1 point. So
All right,
I just
Kevin.
wasn't sure.
It doesn't add or detract from any points that you have there. Really and truly, that's a box for me to use. And the way I use it is, if I have face-to-face class, like for example, that lab that we just did. If I have people that do really good technique and get really, really good results, I've had people get so close that they have 4 results that are within 0.0005 of one another. It's an experiment that you can get really good results. So if there's an experiment that you can get really good results, what I'll do is, if you get the good results, I'll give you extra credit, and that's how I do it. So that's what the purpose of that box is.
All right, roger that.
But unfortunately, because I'm giving you canned data, I can't give you extra credit for that. Make sense?
Yep.
Okay, guys, is there anybody that was confused over reading this laboratory? Is there anybody that read the laboratory?
Yeah.
Okay.
Yeah, I read it.
Was it confusing? Because literally speaking, I read it 3 times before I understood it the first time. We're going to go through it. We're going to get through and understand what we're doing and why we're doing it. So there we go. For sure this PowerPoint is up. Use it as a template in terms of what you have to do for completing this laboratory. I don't need a snooze. Why do computers do what you tell them to do rather than what you want them to do? Okay, this is what I want. Yeah. Okay. Guys, we're using the same principles we used last week. When it's pink, it's neutral. When it's neutral, H plus moles equal OH minus moles. Same basic technique as last week. I'm only going to generalize about the procedure because I want you to paraphrase it in the notebook. Generally speaking, when you're looking at something, it's harder to notice when a color disappears. It's harder to determine when a color appears rather than when it disappears. I don't know why I wrote it like that. Yeah, I'm sorry. I'm a moron. It's harder to discern when a color disappears than when it appears. Do you buy that, guys? If you don't, you have to for this lab anyway. This is a fact. It's harder to figure out when something disappears rather than when it starts to appear. So basically, we always want to approach a titration using phenolphthalein by adding the base to the acid, because the acid's clear. When we add the base to it, that's when we get the color. Is that making sense for you?
Yeah.
Yep.
So what we're going to do, we're going to add excess hydrochloric acid to our amount of antacid. The antacid neutralizes HCl. But if we just drip the HCl in on the antacid, we would be trying to watch when the color disappears, and that's almost impossible to do. So we're adding excess HCl to our antacid. That means there's still H plus in our flask. That means we're going to be able to put NaOH into our excess acid. And when the pink color appears, we're going to know that it's neutral. That's the whole synopsis behind what we're doing today. So in this instance, our total amount of HCl is going to be the moles of HCl neutralized by the carbonate plus the moles neutralized by the NaOH. We're dealing with two different reactions. The HCl and the NaOH is no real problem. It's a one-to-one relationship between the NaOH and the HCl. So the moles neutralized by the NaOH, I can just subtract by the total moles of HCl, and that will give me moles neutralized by the CO3. With the CaCO3, though, there are two HCl's for every CaCl3. So we are going to have to employ, when we're doing this portion, we're going to have to employ the molar ratio. So what we did, we took an antacid tablet. We weighed it. It weighed 0.1045. We crushed it, and we put it under a burette, which read 0.70 milliliters. We added the HCl from the burette until the final reading read 20.70 milliliters. And we also noted the concentration of the HCl as being 0.1057. We noted the original volume of the NaOH to be 5.75. We titrated the solution until it was pink, and we noted the final volume to be 16.80. Okay, understand that we're still using the base we standardized in the previous example. If you did not get this average, use this average. The right answer you should have gotten from last week's experiment should have been 0.09917 molarity. That is the concentration of the base. All right. So, as I said earlier, the moles of HCl that I had in there were neutralized by NaOH, some by NaOH, some by CaCO3. My total moles, I have to take my final volume of HCl, subtract my initial volume of HCl. So this is 20.7 minus 0.7. I have 20.00 milliliters of HCl. I change my milliliters into liters, and I multiply it by my molarity of my acid, and I find that I have a total amount of moles of HCl of 0.002114 moles. Now, the NaOH that was used to neutralize some of that HCl, my original volume of that NaOH was 16.80. My final volume was 5.75. So I used 11.05 milliliters of NaOH. I multiplied that by 1 liter over 1,000, and that gave me 0.01105 liters. Multiplied that by for right now, we're using this as a molarity of my NaOH. Understand when you do it, you are doing 0.09917. So in this case of my experiment, I took my liters of my NaOH, multiplied it by my molarity of NaOH, and this gave me 0.001087 moles of NaOH. That neutralized some of the total HCl. So if I subtract the total number of moles of HCl, the 0.002114, and the 0.01087, this is going to give me the moles of HCl neutralized by my calcium carbonate. Is this making sense? Are we good here?
Yep.
All right. So I make that subtraction. This means I have 0.001027 moles of HCl that were neutralized by the calcium carbonate. I have to remember, there's a 2-to-1 ratio. So if I have 0.001027 moles of HCl, there's a ratio of 1 to 2 of calcium carbonate to HCl. So this means I have 0.0005135 moles of calcium carbonate. I've got the moles of calcium carbonate. I can find the grams of calcium carbonate by multiplying that by 100.09. This gives me 0.05139 grams of calcium carbonate. But you got to remember, my original mass was 0.1045. So to get the mass percent of calcium carbonate, I just take the moles I just got, the 0.05139 grams of calcium carbonate, divide that by the weight of the tablet, multiply by 100. This gives me 49.18% calcium carbonate. Any questions about this? Now, I'm going to make it easy for you guys. You guys get a bonus because you're here. My moles of HCl goes out to 2 decimal places. My initial and final volume go out to 2 decimal places. This means that my volume of HCl goes out to 2 decimal places, sig fig wise. Questions on that? So I now have 4 significant figures of my HCl. I'm multiplying it by my molarity, which is 4 significant figures. So my moles of HCl is 4 significant figures, which means it goes out to the 6th place past the decimal. I take my NaOH, again, goes out 2 places past the decimal, minus something that has 2 places past the decimal. My amount of sodium hydroxide delivered has 4 significant figures. I multiply that by the molarity, which is 4 significant figures. my answer moles of NaOH is 4 significant figures. It just so happens it goes out to the 6th place past the decimal. So when I subtract a number that's in the 6th place past the decimal and subtract something from that that's to the 6th place past the decimal, my answer is going to be to the 6th place past the decimal. So when I do that subtraction, my final answer of moles of HCl neutralized by calcium carbonate is going to be 0.001027, or 4 significant figures. I do the molar ratio. I still have 4 significant figures because these are exact numbers. I then multiply this by the molecular mass of calcium carbonate. I don't want to lose any of my significant figures, so I choose a molecular weight that has more significant figures than the data I have multiplying it by. So my final number is 4 significant figures. My original weight was 4 sig figs, divided into 4 sig figs. My final answer should have 4 sig figs. Are we understanding the sig figs of this problem, guys?
Yes, sir.
Are we good with it?
Yep.
All right, I want to take you back to something else. These are extra slides. And this is something because you are going to need it, nudge, nudge, wink, wink, for the final. What I'm going to do is I'm going to show you what happens when you do a back titration. In other words, what happens is you've added too much NaOH, it's gone too pink, so you have to add extra HCl to your original reaction so that you can figure out what the standardization of your base is. We all understand the concept of what I'm trying to do here.
Yeah.
Good? All right. We have 0.253 grams of KHP. Again, KHP stands for potassium hydrogen phthalate, not potassium hydrogen phosphorus. So the molecular weight is going to be 204.22 and not 71. So I started off with a volume of 0.05 milliliters of NaOH. My final volume was 10.15. It was too pink. So if I have some HCl of known concentration, I can add a little of it to make the solution clearer. My HCl was 0.10 milliliters. My final HCl was 0.25 milliliters. And the concentration was 0.1005. I then put it back under the NaOH and added more NaOH until I got the right color. So, if you notice, the first time I did the titration, I ended up with my final volume of NaOH of 10.15. When I did it the second time, my final volume was 10.30. We're going to change this to that. Okay? So my original final volume was not valuable anymore. I have a new volume. So again, I take the new final volume, subtract the original amount that the burette read. This means I delivered 10.25 milliliters of NaOH to my solution. But how many sources of H plus do I have? What neutralized the NaOH?
HCl.
That's one of them. But where did the main part come from? What was I originally titrating my sodium hydroxide against?
The KHP.
So my total moles of NaOH are going to be equal to the moles from HCl plus the moles from KHP. Does that make sense, guys? Are we good? Somebody give me a hallelujah. I don't even get an amen out of this. Come on, somebody give me an amen that you understand. Or if you don't,
Amen.
all right, if you don't understand, please ask me questions. Because believe me, you will see this again. So my moles of base are going to equal to my moles of HCl plus my moles of KHP. Okay, my moles of KHP are equal to 0.253 times 1 divided by my molecular weight of KHP. That gives me 0.00124 moles of H plus from KHP. Now, remember, I used my final volume with HCl was 0.25. My original was 0.10. I used 0.15 milliliters of HCl. So I take my 0.15 milliliters. This number is going to be very, very small because I have to divide my milliliters by 1,000. This gives me 0.00015 liters times my molarity of my HCl. So this ends up being 0.00015 moles of H plus from my HCl. So I need to add this number to this number to get my moles of base. If I do that out, notice I've got one more place, decimal place for my HCl. So my H plus from KHP only goes to the 5th place past the decimal. My H plus from my HCl goes to the 6th. So my answer can only go out to the 5th place. I do the rough math here, and this ends up being 0.001255. The first 5 is the last reportable significant figure. I look to the right, that number is 5 or greater. I round up. So my total moles of H plus is 0.00126. That's the moles, total moles of H plus. That equals the moles of NaOH. The last thing I have to do is this moles of NaOH was totally within my volume of NaOH, which was 10.25 liters. I divide my moles of NaOH by 0.01025 liters. This gives me 0.122 molar NaOH solution. Does this make sense, guys?
Yep.
Any questions? Please, please, I'm here. I really want to make sure that you do this next one right. If I'm hearing crickets, guys, I'm eating dinner.
Can I ask you a question about the last lab?
Sure, Dylan.
I had emailed you back. Did you get a chance to see it yet?
No,
No? Okay.
I haven't looked at it.
All I did was transpose one number, and you had told me to redo it.
I saw you. No, I saw your email. I'll look at what you did and grade that then. Okay, Dylan?
Okay, all right. Thank you.
No, no problem. Don't do extra work for nothing. Okay, this slideshow is definitely posted now. I will record the, I will save this recording and load it up into the Zoom lessons in the course as well. So you can access it at a later time. If you guys don't have anything more, then we're good. There was something I wanted to
Oh.
talk.
One question, sir.
Just one more thing before I forget. I have not graded your lab notebooks yet. Literally speaking, I was hoping to do that this afternoon, but I had to spend too much time correcting last week's reports. So it didn't get done. Who am I talking with?
This is Khalil.
Khalil.
I just wanted to. Okay, I was a little confused on where you got that last liter measurement
Which one? This one?
that that you divide your moles by.
Okay. All right. When I did the first titration, Khalil, I added 10 point, my final reading of my sodium hydroxide was, my final volume was 10.15. Okay, Khalil?
Yes, sir.
So
Okay.
what happens is I had to add HCl because it was too pink. I added the HCl, it went clear. Then I had to add more NaOH to it. Okay? So the original 10.15 doesn't mean a thing anymore. I have nothing to relate that 10.15 to, but I do have something to relate the 10.30 milliliters. Does that make sense
Which
to you now,
was-
Khalil?
Okay, yeah, and then it becomes 0.001, however,
Yes.
liters, which you divide to get the moles.
Which you multiply. I'm sorry, no. You're right. You're right. You divide that number into the moles of NaOH to get your molarity.
Yeah. Okay, thank you, sir.
No, that's what I'm here for. Anything else, guys? If that's the case, then I will see you next week. Some of you, I will see you on Thursday. Take care. Have a good
See ya.
weekend.
You too.
You too, sir.
Take care, guys.